Students, in this video we are going to solve a problem related to polar plot. So here is the problem statement. A unity feedback system having an open loop transfer function g of s is equal to k divided by s into 1 plus 0.5 s into 1 plus 4s is given, and we have got to sketch the polar plot and determine the value of k, that is determine the value of gain such that the gain margin is 20 decibels. So that is the first part of the question, and the second part is we have got to determine the value of k such that the phase margin is 30 degrees. So when such problems are given, we have to consider first k is equal to 1, similar to what we have done in your Bode plot. Okay, so take k is equal to 1. When you take k is equal to 1, your g of s will become is equal to 1 divided by this term. Okay, and taking this g of s, you continue to draw the polar plot. So for drawing polar plot, you have to take first g of j omega, that is substitute s is equal to j omega. So this term will become j omega and j omega. And you can see that already these terms are in standard format, that is 1 plus s into t format, 1 plus s into t format. Okay. So once you get the g of j omega, you have to get the magnitude and phase. I think by this time you are very familiar in getting the magnitude expression and phase expression. So here is your magnitude expression and phase expression. The corner frequencies are at 1 by 4, that is 0.25 radians per second, and 1 by 0.5, that is 2 radians per second. So the next thing that you have to do is, for various frequencies, you have to compute the magnitude and phase and tabulate it. Okay. So that is the job that you have to do. So students should take the calculator and do it and see whether you are getting such a table. So my selection of frequencies are like this. Of course, if I go beyond this, I can select 2, but I have stopped with this because in the magnitude table, I am able to see crossing of unity. Okay, crossing of unity means the one value is crossed between this 0.87 and 1.3. So that particular point is important. So once that is done, you can this table will be enough. And in the phase values also, this minus 180 degree is crossed. You can see that between minus 174 and minus 184, this minus 180 will be covered. So since in this magnitude table 1 is getting covered and in the phase minus 180 degree is getting covered, I have stopped with this computation. Okay, so now these values will be enough for you to draw the polar plot. So convert all these points to polar plot, connect it to get the polar plot. Okay, so here is the polar plot. If you connect all the points, you are getting like this. And you can also see that since it is of order 3, it is ending in this quadrant. Okay, and it is of type 1, it is starting in this quadrant. Okay, so that also you can note. So after drawing for the polar plot for k is equal to 1, let us compute the gain margin and phase margin for k is equal to 1. Okay, so for this particular plot k is equal to 1. So how to find the gain margin? We have to see where the graph cuts the minus 180 degree line. So at this point, this is the minus 180 degree line. So at this point it cuts. Am I right? What is the magnitude corresponding to this? I think the scaling goes like 0, 0.4, 0.8, 1.2. That means every circle's magnitude is 0.04. So this point will be 0.44. Okay, this point will be 0.44. Okay, and 1 divided by 0.44 will be your gain margin. Okay, so actually this should be 4. 0.44. Your gain margin is 2.27. And how to find the phase margin? You have to see where the polar plot cuts the unity circle. Okay, so this is the circle with the gain a unit 1 unity. So it cuts at this point. At this point you have to note down the phase. So for doing that, take a scale, connect the center point and this point. Okay, extend it, you can get the phase. The phase is minus 165 degrees. So 5GC is minus 165 degrees. So your phase margin is 180 degree plus 5GC. So 180 degree plus 5GC, phase margin is 15 degrees. So gain margin is 2.25 and phase margin is 15 degrees. But the question is, you have got to find the value of K such that the gain margin is 20 decibels. Okay. So what should you do for that? That is what we are going to look in the next slide. So the K value you can find by using this formula GA by GB. Okay. Then you should ask me a question how to find this GB, that is gain at a point B and gain at a point A. Okay. So the gain at a point B is very simple. You have to take the K is equal to 1 graph where the particular plot cuts the minus 180 degree line. Okay, here this gain is called as the GB. Okay, gain at point B. What is the gain at this point? Already we have seen that. What is it? It is 0.44. So GB is equal to 0.44. So first work is over. That is GB value is 0.44. Okay. And the next thing that you have got to do is you have to find the value of GA. How to find the value of GA? Just take this formula 20 log 1 by GA is equal to the required gain margin. What is the required gain margin here? 20 decibels. If it is 30, you have to substitute here 30. Okay. Since it is here 20, I have substituted here 20. Okay. Substitute in this formula and get the value of GA. So 1 by GF, so first 20 goes that side. 1 by GA is equal to 10 power 20 by 20, that is 10. GA is 0.1. Okay. So you got the value of GA. GA is 0.1 and GB is 0.44. So when you divide it, you get the value of K. So the first subdivision question's answer is 0.227. Okay, I repeat it. You have to get the two values. One is GB and another one is GA. To get GA, you use this formula. Please supply here what is the required gain margin. Okay. In decibels. Of course, you have to substitute here the gain margin in decibels because we are using 20 log. Okay. So, and get the value of GA, and GB is nothing but the graph corresponding to K is equal to 1 where it cuts the minus 180 degree line. At that particular point, you have to find the gain. Okay. So, as I said, the GB gain is 0.44. So, just divide it, you will get the value of K. Okay. So, this is the first subdivision. And the second subdivision is you have got to find the value of K for the phase margin to be 30 degrees. Okay. So, phase margin is equal to 180 degree plus 5GC. So, the required phase margin is 30 degrees. Please substitute here the required phase margin and find out the required 5GC. 5GC is minus 150 degree. So, first note down this 5GC is equal to minus 150 degree. When 5GC is equal to minus 150 degree, you will get the phase margin to be 30 degrees. Okay. So, here also there's a small variation in the K formula. K is equal to GB by GA. Okay. And this GB value is always 1 because this is the gain where the K is equal to 1 graph will cut the unity graph, unity circle. Okay. Of course, you can come and see here. So you can see here where it cuts the unity. At this point, it cuts the unity circle. The gain corresponding to this point, and you can see that the gain corresponding to this point is, of course, is 1, isn't it? That's why GB is always 1. GB is always 1. Okay. Because it is the point corresponding to the K is equal to 1 graph cutting the unity circle. When I say unity circle, that itself means that the gain is 1. So, GB is always 1. Your work is to find only GA. Okay. So, how to find GA? Please come back to this graph. The required 5GC was minus 150 degrees, am I right? So now you have to find where the curve cuts the minus 150 degree. Okay. Where the curve cuts the minus 150 degree. So I think minus 150 degree line is here. Okay, minus 150 degree line is here. The curve cuts the minus 150 degree at this point. You have to note down what is the magnitude corresponding to this point. Okay, so you have to note down the magnitude corresponding to this point. The magnitude will be like this is the magnitude 2. So the next line will be what? 2.04. So the magnitude at this point is 2.04. Okay, so come back here. You substitute for GA 2.04. GB is always 1. Okay. So how to find this K value? GB by GA, that is 1 by 2.04. This 2.04, how to get this value? Where the K is equal to 1 plot cuts the required 5GC. That's it. The required 5GC is minus 150 degree. So the plot has cut the 150 degree line at the magnitude 2.04. So I have substituted this 2.04. Okay. And this is always 1. Okay. So 1 by 2.04 is 0.49. That is the value of K. So students can use this procedure if the transfer function contains a variable K. Okay. And then they ask you to find the value of K for given phase margin and given gain margin.